So I'm sure you've heard of Bun, the JavaScript runtime all-in-one toolkit, one of the largest Zig code bases ever written. Well, it just got rewritten in Rust. And not only was it rewritten in Rust, but AI rewrote it in Rust. And on both of these accounts, this is a fascinating story. One that started about a week ago when Jared Sumner, the creator of Bun, wanted to experiment with AI to see if it could successfully port the Zig code base over to Rust. Well, if you look at this merge from earlier today, you will see that that experiment was a success, with over 1 million lines of Rust code being added to the main branch of the Bun repo. A repo that I cloned to see what we're actually looking at, which right now is about 720 actual lines of Rust code, not including comments or blank lines, 571,000 lines of Zig still, TypeScript, JavaScript, C++, and C. Now you'll see that there's almost 1,300 Zig files in the repo. About 1,200 of them have a Rust port sitting in the exact same directory with the exact same file name, just .rs instead of .zig, with the other 120 or so being mostly third-party Unicode libraries that Bun pulled in years ago. So if you're wondering why there's still Zig there, it's because the Zig has yet to be fully deleted. It merged the Rust code in with the Zig code so that they can coexist. Rust is now the default, and then on the following PRs, Zig is going to be slowly stripped out. And when it comes to your PRs, you should be using Greptile, the sponsor of this portion of today's video, to review them. That's exactly why Greptile was made. It is the AI code reviewer. Because believe it or not, humans are not perfect. And sometimes we let bugs or just not quality code fall through the cracks. So it's nice to have a second set of eyes to look over every single pull request that comes through and review the code. And how it works is that Greptile indexes your whole code base. Then when a PR comes in, it implements a swarm of agents to review it. And you'll receive a message, something like this, that talks about the pull request, what the code does, a prompt to fix it with AI if you so wish, and oftentimes a confidence score. And over time, Greptile learns your code base, better understands it, and also you're able to set rules so that it properly adapts to your code base for how your team works. And if you want to try it out, you don't have to create an account. They actually just came out with this new PR review tool where you don't have to sign up. All you have to do is come over to a pull request, copy it, paste it over here, and click Review PR. Then you're prompted with what you want to include. A PR summary, a confidence score, issues table, a diagram. Yes, for all of those. And I'm going to set it to a medium strictness level in all of the different comment types and start the review. It goes through 14 different steps. And here is our code review. You have the PR summary. The confidence score was a 4 out of 5. Important files that were changed in this PR. And then the flowchart, which I love the flowchart because this is how I visualize things and how they work. And down here, you'll see for this specific PR, it left 2 inline comments that you can read through, better understand, and then see if this suggestion is something that fits your team and works for this pull request. So make sure you click the link in the top of the description so they know that I sent you. I'd really appreciate it. Back to the video. Let's take a look at the actual code base. The most interesting file that I saw in this whole rewrite isn't even a Rust file, actually. It is the porting.md file, which I want to go over first because it'll better help us understand when we take a look at the Zig file, the Zig code next to the Rust code. Because yes, we're also going to be doing that in this video. So the porting.md file is something that Jared, and presumably with AI, after all, Bun was acquired by Anthropic earlier this year, so they're going to be heavily using AI one way or another. And this porting.md file is the blueprint that AI agents read and follow when doing the port from Zig to Rust. And there are about 300 rules across type mappings, idiom translations, naming conventions, band dependencies, and it opens with this. You are translating one Zig file to Rust. Read this whole document before writing any code. The goal of phase A, this is phase A of the port, is a draft RS file next to the Zig file that captures the logic faithfully. It does not need to compile. Phase B makes it compile crate by crate. So this means that they're not going to be using the best Rust practices. This is a faithful port one-to-one, or at least as close as they can get. And what you'll see in the official merge to main, the official PR message that Jared left, is that it passes Bun's pre-existing test suite on all platforms and fixes several memory leaks and flaky tests, which is actually very important to note that when you have a pre-existing test suite, that allows for a much more accurate port from language to language. Without something like that, it's not going to be as clean. The binary size shrinks by 3 to 8 megabytes. The benchmarks are between neutral and faster. Yes, these benchmarks are saying that in this instance, Rust is faster than Zig, which is one of Zig's main selling points, is about how fast it is. And most importantly, we now have compiler-assisted tools for catching and preventing memory bugs, which have costed the team an enormous amount of development and debugging time over the years. The code base is otherwise largely the same architecture, the same data structures. Bun still uses few third-party libraries, no async Rust. So really the only thing that's different here is instead of it being Zig, it is Rust. Don't take any other sort of paradigms into consideration, just this one thing. And what does that actually look like? Well, here's a small one. It's an SSL mode enum from the MySQL driver. Zig is on the left, Rust is on the right, literally in the same directory, by the way, and you will see that it is the same exact shape. It is nearly identical. You have Rust attribute syntax instead of Zig's enum. You have the same variants. And notice the comment at the bottom, ported from, well, that file above. This is what you will find in every single new Rust file in this repository. And I only mention that because it's something that the agents did. And it's a way to keep track of where that code came from. So that way a human reviewer or an AI reviewer knows this Rust code was ported from this Zig code right here. And presumably this comment will stay there as long as the Zig file is still in the code base. But enums are easy to port. I mean, that was a very straightforward one. Here's a more interesting one, an HTTP header value iterator, which does go from 18 lines of Zig code to 44 lines of Rust code. However, it's more like 33 if you're not counting the comments. But we have a full explanation as to why there are so many lines of Rust code left by the agent. It's because Zig stored a token iterator field. The Rust equivalent is this slice here, which has an unnameable closure type. So we store the remaining input slice and inline the tokenized by logic in next, but the behavior is identical. Or if we want to break that down, because Zig has a built-in tokenizer type that the original author just stored as a field, but the Rust equivalent has a type signature you quite literally can't write down because it has an anonymous closure. So the agent just decided to make its own tokenization. And you will see this pattern repeating again and again throughout this code base. Zig is typically shorter. Rust is going to be more explicit. To be more explicit, typically need more code. And the agent will leave that port note when something like this does happen. And now, I did see this comparison a couple days ago that went a little viral. It was a comparison of the existing Rust code in UV to the new Rust code in Bun, where in Bun, it counted over 13,000 unsafe blocks, and UV was 73 unsafe blocks. So the general sentiment seemed to be that, hey, they're not writing Rust, they're writing C++ with Rust syntax with all of these unsafe blocks. Because Bun embeds JavaScript core, libuv, uWebsocket, several C and C++ libraries, these usages of unsafe are reasonable and expected. This will get better though. However, Jared specified, hey, this is a faithful port. There are going to be a lot of unsafe blocks because they're coming directly from Zig, but we are working on decreasing the amount of unsafe blocks. And he said somewhere, if I can find it, I'll show you. He said somewhere that it'll probably stabilize around 10,000, which it did, which is still a lot more than, 73 unsafe blocks like UV has. But the reason being is because he said most of Bun is written in C and C++. That's not going to change. But that only explains about 2,400 unsafe blocks that are in the FFI bridge directly, which are the bindings to JavaScript core and the raw C libraries that Bun uses. Those are unavoidable, but the other 8,000 or so, well, those come from porting the Zig code faithfully, and we'll get to that. But besides that, whatever you want to think about that, what I want to know is, did AI actually write good Rust code? It all works. It's doing well in the benchmarks. That's all fine and dandy, but I want to look at the actual code. So that's what I did. And I found some Rust code that is quite a bit better than the Zig code that it originally was. And here's the Zig version. You see this line right here. This is a call out to a C++ function to get the VM pointer. Every single time bun VM is called, the code jumps over to C++ and then comes back. Now look at the Rust version. I mean, you can even see it preserved the original comments that Jared made over a year ago. But look at this line right here at the bottom. This reads the thread local directly in just one assembly instruction, skipping the C++ shim function entirely. And in this comment right here that the agent left, you'll understand why. Cross-language LTO does not inline that C++ shim into Rust callers. Found that in the release binary, the Zig version produces 905 out-of-line call queue sites, whereas the Rust version produces 0, because, well, it never goes through C++. Then it added a debug assertion in case that assumption ever breaks. And something else I noticed is that, maybe this is just me, when you try to vibe code with Rust, or in Rust rather, you get a lot of to-do macros. But in this, there were no to-do macros. There was one unimplemented macro, but that's it, just one. Now, a lot of people are trying to dive into the Rust code base and take a look at the Rust code base and things that may be wrong here and wrong there, but nobody seems to be talking about the Zig code base, because when you dive into the original Zig code base, you will see that there are over 2,500 raw pointer manipulations. And what that means is every single one of these is memory unsafe. And every one can produce a use after free, an aliasing violation, a misaligned access, which are the same operations a Rust unsafe block does. So while in Zig, you don't actually type out unsafe like you do in Rust, there are these things that are memory unsafe. And because Rust's unsafe surface is more granular than Zig's, one Zig pointer operation often becomes multiple Rust unsafe blocks. That's presumably where a lot of these 8,000 unsafe blocks come from. And if you actually dive into the Rust code base more and more, similar to what I did, you will see that this is actually fine Rust code. And if it was bad Rust code, I'd be the first one to tell you that it is bad Rust code. It is not idiomatic Rust or Rust we'd write from scratch. I want to be clear about that. It reads like a port, but it's a competent port that passes Bun's existing test suite on every platform and performs about the same or faster than the original Zig code. It's definitely not what one should consider AI slop. Now, why? What did Bun get out of this is the real question. Is it a good marketing ploy for their parent company, Anthropic? If it all works out well, then heck yeah, it is. I mean, I'm not going to pretend that it isn't one of the potential reasons why they did this. But there's more than that, and I discussed it throughout this video. It passes the test suite on all platforms, fixes several memory leaks and flaky tests, binary size shrinks 3 to 8 megs, which we discussed, benchmarks neutral to faster, which I discussed, and likely closes about 200 GitHub issues, presumably because the bug class those issues belong to just can't exist in Rust. However, what I think a real big reason for this rewrite is because of Claude Code. All roads lead to Claude Code. And that's because Claude Code ships as a Bun executable. It is a Bun executable, and there have been some reported issues with it. Well, there's been a lot of reported issues with it, but specifically where the main process climbs from 1.7 gigs to 14 gigs of RAM in minutes. And another one hit 23 gigs after 14 hours and froze the whole system. And now not every memory leak gets fixed by this port, nor was it caused by Zig. because the reporter on the first one attributed it to Bun's WebKit malloc allocator, which is the C++ heap inside JavaScript core that Bun wraps. So regardless of what language is wrapping the JavaScript core, Zig or Rust, it has no say over that. But it does fix a lot. And if that's the main reason, I don't actually know, but it's an interesting one. But what I really hope is that Bun doesn't follow in Claude Code's footsteps of being one of the most buggy pieces of software that I actually use. It may happen. Anthropic does know how to make buggy software, and since Bun is under Anthropic, it may be the case. But from all I can tell, the Zig to Rust port, the Rust code is no lower quality than the Zig code. There were a lot of memory unsafe things with Zig, a lot of issues with Zig. There's still some issues with the Rust code. Don't get me wrong, it's not perfect, but it's comparable. And the fact that AI was the driving factor behind this, again, is I think one of the biggest reasons why this happened, because it's all under Anthropic. So really, only time will tell how stable Bun is moving forward with the Rust code base as they remove more and more of the Zig code. But from a third-party perspective, it has been a fascinating watch. From the porting.md to it actually happening and being merged into main. Let me know what you think, because that's all I got. I'll see you in the next one.